Hi, everyone. I just want to go through quickly what I did in our Google Meets this morning and some of the afternoon ones. Some people got cut out or the power went out. It went out for me at school here as I was doing some stuff during one of the hours. So I want to make sure you know what to do, you get all the information, and you see the demo. So if you missed any of the Google Meets as well, here it is. All right. So first, I wanted to make sure the agenda was clear, that you knew what to do, you knew what was due when. I tried to set it up so it was more like a homework, and then what are we going to do in class? So kind of like you're going to do this material, these things before you're prepared to come to class. So that when you come to class, we've all done the same things and we're able to talk about them or answer your questions and stuff. So kind of get in that habit. If my agenda doesn't make sense, or you don't know what I'm asking you to do, or you have an idea of how it could be better, please tell me so I can fix it and make it better. I want to make it clear for you. I want you to be able to find stuff and not spend time searching and trying to figure it out. All right, so for today, you should have looked at the syllabus, done the syllabus quiz, signed up for Remind, and filled out that All About Me. If you haven't done those, make sure you do those quickly, as soon as possible. So then before Monday, when I see you all again, you have some safety stuff to do you have a safety video to watch, the rules to read, a safety quiz to answer. And then there's a lab equipment I got a sheet with pictures, and then a quizzes for you to fill in with different pictures to make sure you kind of become familiar with some of the lab equipment. What I'll do in class on Monday is, so please come. It's not just questions or if you need help. On Monday in class, I'm going to go through the safety equipment and things that we have and talk about a few of the safety rules. So I'm going to show you kind of where things are, whether you're going to be in the room or not. And then I'm going to show you what some of the lab equipment is, because it's different seeing it in like on a picture or on your screen versus, I mean, you're still going to see it on your screen, but seeing it like next to someone, kind of size and all that stuff. Okay, so let me do the demo, and then we'll be done. I'll try to keep this short and sweet. But the point of this demo is I want to remind you about kind of how to do science, how to be successful in this class. So I have a few things here. This is an Erlenmeyer flask with a sidearm, meaning it's got this tube coming off the side, and I have tubing connected to it. I've got a rubber stopper to cap it. I have a large beaker here of water. And then and I'm going to put my gloves on actually, because I am kind of known as a bit of a messy chemist. It's not the best quality, but it is what it is. It's true. And I tend to sometimes get stuff on my hands, and the next thing I'm going to show you is pretty nasty stuff. And if I get it on my hands, which you can see I would have because it's on my gloves. I don't know if you can see like all those little brownish yellow spots. That's where it got me. And if it would have been on my skin, it would have turned my skin that yellow brown. It gets really hard and kind of kills those skin cells. And then I kind of have to peel it off, and then I get new skin, and it's gross. And my husband always gets a little annoyed with me when I don't wear gloves because I'm not protecting my hands. And I don't know, it's this crazy thing where he like cares about me and he wants me to be safe and stuff. So I suppose. Okay. Anyway, the thing that got my hands all yellow and gross is this. This is nitric acid. So nitric acid is pretty strong acid. Like I said, it'll do all that stuff to your hands. Okay, so I got the nitric acid, and then I have a penny. And this penny is made before 1982, which means that it is solid copper. So pennies made after 82 have a zinc core, so zinc in the middle, and then they're just copper coated. And the reason they changed how they made them was the amount of copper that's in this penny before 82, the copper itself is worth more than 1 cent. So then it's actually worth more than a cent. And so then it's not profitable anyway, but it's not appropriate to make it that way. So that's why they changed it. All right, don't go melting down pre-82 pennies though. It's illegal. Okay, so before I do anything, I want to tell you a little story. So there was a man named Ira Remsen, and he was a chemistry professor. He actually founded the chemistry department at a really famous university out east called Johns Hopkins University. And he one day was reading in a book, and in the book it said nitric acid acts upon copper. And he was like, I'm so tired of just reading about things. Like, I want to do them. I want to observe them. Like, I don't want to just be told this is what happens. I want to see it for myself. And he was like, and what does this acts upon mean? Like, define that. Acts upon. What does that mean? Does it just sit there? Does it bubble a little bit? Does it slide off the table if I do it? Like, what would happen? So he found a penny for copper. He found some nitric acid. He put the penny on the table and he poured the nitric acid on top. And he wanted to observe. Okay, so let's do what he did. Let's observe, because to be honest, I hope you are this way, because I know I am. I sometimes get tired of just talking about it. Let's do it. Let's figure it out. No, I'll leave it this way. Okay, so I'm going to put the penny in the Erlenmeyer flask. I'll tilt this down a little bit too. Okay. All right, I'm going to take my nitric acid, I'm going to pour it over there, and then I'm going to cap it. I don't know if you can tell at home from the video, there's some vapors there. All right, we've already got stuff happening. So think about, what do you see happening? What are some observations you can make? I assume you can see that the solution is turning green. You see a color change. I think you also probably see that kind of brown-red color up above. And then, I don't know if you can see or not, but where the penny is, there's some bubbles coming off of it. All right, can you see the bubbles in there? Those bubbles are gas being formed. And you can probably also see now the bubbles coming through the tubing. So the penny and the nitric acid are reacting. This is that act upon, right? They're making this gas. The bubbles tell us we have a gas formed. And the gas is this reddish brown substance in here. And let me tell you that if you can see a gas, so if it is colored, okay, it is for sure poisonous. So this gas is poisonous. So if I didn't have this cap on it or this tubing hooked up for it going through the water, I'd be coughing a lot. That doesn't mean if you can't see a gas, it's safe. Like carbon monoxide, you can't see, it's not safe. Okay, so while this kind of happens, and it's going to keep going until the penny's gone. It's going to keep bubbling and reacting. Let me tell you what happened with Ira Remsen. So he did this on the lab table. So think about this stuff happening. And by the way, this is warm as well. So this gets really hot. So this is happening on the lab table. This gas is fuming and he's coughing and choking as this happens in front of him. And he's thinking, oh my gosh, this is what acts upon mean. He's like, what if... Or he's like, this is such a mess. I got to get rid of this. So he takes it with his hands and he scoops it up. And then he learned something else. He learned what acts upon means in terms of the nitric acid in his hands. So nitric acid acts upon hands as well. So his hands are burning. It's such a mess. And he thinks, I got to get it off my hands. So the first thing he does is he wipes it on his pants. And he learns that acts upon nitric acid acts upon pants as well. So he learned a lot that day. He learned what acts upon means in terms of nitric acid and copper, and then also hands and pants. But he also learned that if he asks questions, if he makes observations, he can learn a lot more than just reading about it in a book, let's say. That's what you're going to do this year. Whether it's virtual labs, whether it's in-person labs, you're going to get to see and do and observe, and you have to ask questions to get your answers. Otherwise, you will struggle. So ask questions, make observations, okay, and learn. Now, there's one other thing this demonstration can show, okay, and because there is one more thing that it does. But the thing about this last piece is it's kind of the coolest part, but it takes a little bit of time. It doesn't happen right away. So this is kind of like in class. There are going to be times where you don't understand what's going on. You might not understand right away, and maybe someone else does, but be patient. You will get it. You will figure it out, and it will be worth it. But please don't give up. Be patient. Wait. Work hard. Ask questions to get the help you need. Now, while I said that, now we also have to wait. This is very warm. For the bubbles to stop here. And it's going to do one more thing. Okay, so this is the great part where we have to wait. So I can tell you my chem joke. Remember I said I'm a messy chemist. I'm also a messy cook. But cooking and chemistry are essentially the same thing. Cooking is chemistry. You're doing reactions when you're cooking. You're mixing things together, you're using heat, all that kind of stuff. What is the difference between chemistry and cooking? If you want to pause and think about it for a while, you can. All right. But I will tell you that the main difference is in chemistry, you cannot lick the spoon. I know we're over video, so I can't hear you laughing, but I just feel that you're going to. I know you think that's hysterical. Okay, so no licking the spoon in chem. It's one of the safety rules you're going to read about for Monday, is don't eat or drink in the lab ever. All right, we're getting close. We're getting close. Come on. Okay, it's about to go. Come on, you can do this. Oh, here we go. Oh, that was beautiful. All right, so what happened? The water rushed up from this beaker through the tubing into here. So notice, no more Penny. Penny's gone. Because the copper is now mixed with part of the nitric acid, and it made this, which is copper nitrate. This was the same stuff I had in that one of the middle Petri dishes. So copper nitrate solution. Why did this happen? Should be the question you're thinking about. It happens because of a pressure change. When the gas leaves here, the pressure is low, which means the air in there is not pushing much at all. The pressure out here hasn't changed, so comparatively, the pressure out here is high. So when the difference is high enough, and this is really high, there we go, now you can see my hand on the screen. This one's really low. This is gonna push back to equalize it. So the water rushes back to equalize the pressure. And we just made copper nitrate. Chemical reaction means we made something new. We made a new product. So that's what we went through. If you missed class or got cut out, or I cut out and you couldn't see the rest, I will see you on Monday.